Hello, flatties and globe defenders. It's Critical Thing from Down Under, and today I've got a video about some sunrise observations, and in particular the sun rising from below eye level. This, of course, is impossible on a flat Earth, and yet this is what we observe, and this fully supportive of the globe. So there, flatties, I'd like you to take a look and see if you can tell me how these things are possible on a flat Earth. But just remember to keep it civil. Thank you.
This story starts September the 1st, 2018, when I took some photos and video across from Mount Cootha to Brisbane City, and on this particular day was a dust storm, and you can just see the sun rising through the dust if you watch that building to the right. I'll start playing now. Now you can just see the sun start to appear there if you look closely. So there it is behind that building, and I'll show you a little bit later in this video where eye level is. It's at the top of that building. So what's significant about this? The sun is below eye level, and I can zoom in there. The time is 6:04 in the morning, and the sun is just coming up. So the sun is shown there as below eye level, which is an impossibility on flat Earth. If you draw a horizontal line from my observation point, the horizontal line, the tangent to the Earth, intersects that building at the top, and the sun is below that. Now that violates the flat Earth law of perspective in that something that is above you cannot, by perspective, go below eye level. So that's impossible on a flat Earth. That just can't happen. But I hear that there will be some skepticism from flat earthers who refuse to believe the facts. Now here's my observation point at Mount Cootha observation point. This was where I've taken a series of observations, and that was the one on 1st of September 2018, and the building is at 1 William Street, which is on this view is still a hole in the ground, but I can assure you that the building is there. You've just seen it in a photograph, and yes, this particular building is about 4 miles from the observation point, and in a direction of approximately 81 degrees. So this is the building, and by the plans that they have, the top of the height of the building, up the top of that spire, is 260 meters. The top of the occupied floors is 180 meters. So that means that where I'm lining up the top of that building itself without counting the spire is around about 220, 230 meters in that region. And because the building itself is a few meters off the ground at ground level, so the exact number is in the range, is in a 10-meter range, 220 to 230 meters. Now this timeanddate.com is the heliocentric prediction of the sun angles and elevations, etc. And if we go back to 1st of September 2018, the sunrise is at 81 degrees, and that's that bearing of that building from that observation point is 81 degrees. Now we go to April 2019, and when we've got a similar situation around about 80 And on the 13th of April 2019, it was also at 81 degrees and around the same area, so I could get some more pictures from the from the same site with the sun over the city. I've come back in January 17, 2019 to do another different type of measurement. Now the top of this building, I've said, is about 230 meters. The observation height at Mount Cootha, you can look it up, it's in my other video as well. It's about 230 meters, somewhere between 220 and 230. This is between 220 and 230. So it's a very similar height. And now I went back on January 17th to verify by a different method that it's the same height. I verified this 230 meters by reading the plans for the building, and that's what they said, that the height of the building. The height of Mount Cootha is documented elsewhere, and these two match up. So if you draw a level line between the observation point and the top of the building, that will be level. That will be a tangential line from the observation point, perpendicular to the plumb line that you would suspend at your observation point. So that's eye level. So I've set up my Flatbuster Mark II to determine and verify that that is indeed eye level. And the other thing you need to notice is that that is eye level. The horizon is well below eye level. There in this picture you can see the horizon there. There's some sand hills and mountains to the right above the horizon over to the left. So Flatbuster's set up. Now remember again that there's two spirit levels. The one on top is upside down and it doesn't work upside down, so do not take any notice of that bubble on the upside down spirit level. It's not designed to work upside down. However, this one on the bottom is also got a digital readout of the degrees. It also works upside down, so you can see the bubble is in the correct position when we're showing 0 degrees, and it's held up against the other one by the tape. So we'll roll this video now. As you can see, eye level is at the top of that building. So that's a level line from your eye to the top of that building. That's eye level. And you can see the horizon is well below eye level, which of course means curvature. Now some people have given various excuses for the horizon drop, and we'll get into that in a minute. So here's a still picture I took, which shows looking down the tube, and you can see that the top of that building is fair smack right there at the level. So people have come up with various excuses to try and, flat earth people had to try and explain away the fact that the horizon drops from eye level and therefore the earth is not flat. So in their minds they consider that this is an impossibility because of a belief system rather than any factual data. So when the factual data disagrees with what a flat earther might think, then they must come up with some kind of explanation to save face for themselves and to rescue their belief. So in this case, various proponents have mentioned things like limit of sight, angular resolution limit, I don't know, just crazy stuff. And one of the most, it's an optical horizon. That's the latest one. The latest one is it's not a real horizon, it's an optical horizon. Well, of course it's an optical horizon, otherwise how could you see it? And all those buildings are optical buildings as well. But anyway, I think what they're trying to say with the optical horizon thing is that it's some kind of trick of optics, so that the horizon would indeed be higher if there was not this trick of optics or whatever that is. I'm not really sure what it is, but there is some variation in the horizon height due to refraction conditions, but it's only 0.04 of a degree at most, and this here is more than 0.4 degrees. The argument is that the horizon does indeed rise to eye level, you just can't see it. And here's where the sun rising below eye level destroys that particular argument. And we've already seen a picture of the sun shining through, so the horizon can't possibly be that high because the sun cannot shine through the horizon. So there's nothing optical about it. That's where the physical obstruction is. And we've got more video to make that, more pictures, more video to make that obvious. On January the 24th, 2019, I tried to capture the moon rise. Now it's very difficult conditions, as you can see, quite a bit of refraction going on. But then again, there, as you can see, the moon is below eye level, can be seen there, the horizon is not there. Then, okay, and I've said before, okay, around in April, the angle of the sun becomes such that it's in a similar position to what it was in early September, so I've gone out to try and capture some more sunrises. Now, not a good day on April the 6th. Clouds. There's nearly always clouds, so it's very difficult to get a good day. But there you can see the sunlight behind the buildings, and which shows if there was a horizon and it was optical, the sun wouldn't be able to shine through it. And there's the sun to the right. The sun is below the top of the building, so the sun's shining through there. It shines through the clouds, but could not possibly shine through the earth. And remember, there's some mountains there, so it's not just water there. And there's the horizon line I've drawn in. Sorry, not the horizon line, the eye level. And the sun is clearly below eye level. That's impossible on if the sun was above eye level, as they say in a flat earth world. But on a globe, that's perfectly okay. So here we see flat earth impossible, globe perfectly okay, direction as predicted, height above the horizon as predicted by the globe, but none of that fits a flat earth. And we'll talk a little bit more about that later. And here again, that was that particular photo was taken with infrared, I should have said. And here we've taken with the normal camera. The sun is again below eye level. It's rising below eye level. And I must stress again that this is impossible on a flat earth. This also means the horizon is not an optical horizon. There is no obstruction. The obstruction is below where we see the horizon. So where we see the horizon is the horizon. So it's not an optical effect because the sun is shining from behind the horizon and it shines through the atmosphere, not through the flat Earth. So the horizon dips and therefore there is a curve. It's pretty simple stuff really. And I've just changed the exposure to get that picture. And I've taken infrared picture, and you can notice on the back of the camera there's a little infrared light. You don't see that in normal daylight. It's coming up. Again, now the next day, which is Sunday, I get out to go to watch the sunrise again. And this is pre-dawn. And there's another interesting thing that we can see here. So, of course, the sky is lit up behind the horizon. The sky is orange, the land, the water is, and the land is not orange. It's very easy to see that this is not an optical effect. The sky is uniform in color all the way down to the waterline. The sky is a different color to the waterline. And also something else which makes the flat Earth impossible here is there are clouds that are below eye level. Now again, this cannot happen due to perspective. The clouds are above you. They will always be above eye level due to perspective. These clouds you can see in the distance are below eye level. And they're also in that area that flat earthers like to say is some kind of optical effect which make the horizon drop. But the horizon is a solid horizon at that line because you can see the sky behind it and you can see the clouds. Now, if that was some kind of atmospheric blockage, you would not be able to see those clouds in the distance, and the color of the sky would not be so uniform. Where your real horizon, if you had a real horizon on a flat Earth, there would be some kind of delineation, but you cannot see it. So it's impossible for the Earth to be flat just by looking at this photo. Totally impossible. But there you go. Never let facts get in the way of a good story. And I've taken an infrared picture, zoomed in a bit. You can see the clouds below eye level. It's a no-brainer really. And here just before, I believe this is just before sunrise. And the sun coming up. Now I haven't got a solar filter on this lens, so there is some flaring, and that's overland, so that's not a reflection. That's actually an optical effect. Now that's what an optical effect can look like. The sunlight is flaring there in the lens. And again, optical effect of the sun. The sun is actually above. It cannot be carving a hole in those mountains or sand dunes. This is an optical effect in this case, but there's the sun there, but still below eye level. More of the same. And also interesting here, the sun shining on the underneath of the clouds. Now with infrared this becomes much more obvious. There's sun shining on the bottom of clouds. Another impossibility it's impossible to happen by perspective. It's impossible to happen geometrically on a flat Earth. This can only happen on the globe Earth. So all kinds of optical lens flaring, and it's reflecting off my IR filter and everything there, but it's still horizontally below eye level. And now I've got a bit of a video taken from the sunrise. I'll start this. So this is over one of the islands. I think that's Stradbroke Island. Can't remember whether it's North Stradbroke or South Stradbroke. And you'll see the sun pop up here shortly. There we go. So there, that's not an optical horizon. The sun's shining right through the atmosphere. There's no blockage behind it. There's no limit of sight. There's no angular resolution limit. You can see all the way to the sun. In globe model, that's 93 million miles. So there's no flat Earth rising up to eye level. The Earth curves away. So that's sufficient so you can see your eye levels at the top of that building. The sun's below eye level. That's very conclusive, very clear that horizon is not an optical effect. It's a hard horizon. April 13, and again clouds. April 14, clouds on the horizon again, but there we have underlit clouds. You'll notice that the cloud up there, it's high in the sky, it's lit underneath. The clouds that are lower in the sky, there's no sun shining on them at all. On a flat Earth, that would look totally different. And here's an infrared where the sun's getting a little bit higher. It's still shining underneath those high clouds, and you're starting to see it on the top of these clouds down at the bottom. And as I said before, this picture, dusty conditions, so there's no moisture in the air, so there's no lensing effect because of moisture, but there is some refraction because of different density layers and that. So here's another thing about this sun. It's still big, and the angular size of the sun stays the same all day, and that means it's a faraway sun. On a flat Earth, the angular size of the sun would be significantly different. So from this picture, I calculated the angular size of the sun. So you can go through this calculation for those who wish to, but from the picture itself, I measured this 31.8 arc minutes, and the sun is about 32 arc minutes wide, so that's a pretty good in very, very close. And compare that to how the sun should look due to perspective if it was a close and local sun. It should be a quarter of the size roughly, 8.46 arc minutes, but it's not. It's flat Earth. Due to perspective, on a flat Earth, the sun would be 8.46 arc minutes. It's not, it's 32 arc minutes. So there's another problem, big problem for flat Earth, which shows clearly that the Earth cannot be flat. The sun is not local, and that's how it's shown. And the direction of the sun too is wrong for a flat Earth. Timeanddate.com predicts the position of the sun exactly. So I did this diagram, which I did back in September. The orange line is easterly direction. The yellow line is the direction that we observed the sun, as predicted by the heliocentric model, and the green line is where the position of the sun would be on a flat Earth, and you can see that it's a totally different direction. So how can that possibly be? I mean, the sun's not even in the right place for a flat Earth. And I did the calculation also for the elevation of the sun. So we'll go back to here. This is a triangle, 7,830 nautical miles, 5,200 nautical miles this way. The distance of the sun is 9,000 nautical miles, approximately 2,600 nautical miles high, and that gives an angle, you can't see that, it's very small, but that gives an angle of 15 degrees. Now flatties, for the sun which should be 15 degrees high in the sky, how can it possibly be observed at the horizon? That's just not possible. There could not possibly be that amount of bending of light. Just let me put this in perspective, so to speak. This here, the green line, is 1 degree. Now, the amount of refraction that would allow a laser to be seen over a 10-mile stretch of water would be 0.032 degrees. And flatties like to say, well, that's just not possible. The Earth must be flat because you can't have refraction laser curving over water. They'll deny 0.032 degrees because it doesn't suit their narrative. But then they'll go right ahead and say 15 degrees is possible for the sun to appear on the horizon instead of way up in the sky. I'm going to make then the score. How does the sunrise, how does it support globe or flat? And so because the sun has been shown to rise below eye level, impossible on a flat Earth, perfectly okay on a globe. The direction that the sunrise, perfectly predicted by globe, impossible on a flat Earth. At 81 degrees, it's approximate in a flat Earth. That's about 40 odd something degrees out. The sun would be way to the left on that picture. It's just impossible. I don't know why flat Earth believers just ignore these things. They're fundamental. They're crazy. The angle of the sun. Now also the elevation angle. It should be 15 degrees in the sky on a flat Earth. Not to mention, way over to the left. So, but the globe predicts it perfectly. There's no crazy explanation required. The heliocentric model predicts it. The flat Earth model, where the flat Earth model predicts it, it doesn't even appear anywhere near there. And all right, the sunrise observations, all right, the angular size of the sun agrees with perspective for a globe, doesn't agree with perspective for a flat Earth. Clouds being below eye level, impossible on flat Earth. They cannot, anything above you in height cannot appear below your eye level due to perspective. Even Phuket Word knows that. So there's a win for the globe and fail for the flat Earth again. And clouds lit underneath can only happen on globe. Impossible again on a flat Earth. So there's a score of 6 for the globe and 0 for flat Earth. And yet the flat earthers will continue despite this overwhelming evidence.
Look, you stupid bastard, you've got no arms left. Yes, I have. Look! It's just a flesh wound.